What's going on, Algebros? Mr. C here, and I'm going to show you how to sketch a logarithmic function using transformations. This actually happens to be example number 4 on page 5 of the section 6.4 note packet. I'm going to go ahead and show you how to sketch the graph of f of x equals log base 1/3 of negative x, and then trailing at the end is plus 2. Very first thing you want to do is note that the base of the log is a value of a that's less than 1. Because of that, here's how our log should be starting out. It should be starting out on the right-hand side near the top of the y-axis, decreasing down to intersect the x-axis at 1, 0, and then slowly rolling out down to negative infinity. That right there would be our base graph. Keep in mind that there's also a vertical asymptote along the y-axis. In this function, there's actually an indication of a reflection. For instance, notice inside of the argument of the log we have a negative in front of x. Because the negative is on the inside, what this is going to do is force a y-axis reflection. So what we'll do is, with graph 1, we'll reflect it across the y-axis. My suggestion would be to take the x-intercept of 1, 0, mirror that across the y-axis. It's now going to be at negative 1, 0, and then to split the base graph up into 2 parts for your reflection. If you look at the part that's in quadrant 1, when you mirror that across the y-axis, it should look something like this. And then the part that's in quadrant 4 is going to get mirrored across the y-axis, and this part now is going to look like it's going down to negative infinity, but towards the left. So that is your y-axis reflected base graph. Call that graph 2. There is one more transformation involved in this function, and that deals with the trailing 2 that's at the end of this function. As with any trailing numbers with the function, that's a vertical shift, and because this is a plus 2, we're going to be moving our graph up by 2. So remember, your next transformation is based on your most recent one. So what we'll do is take our red graph, or y-axis reflected graph, and move this up by 2 units, like a g-unit. To start out, let's use the new location of the original x-intercept. That's going to move up by 2 units. So move that up by 2. It's going to be right there now. Now technically, your vertical asymptote, which is along the y-axis, is performing all the transformations as well. If you reflect the y-axis across itself, it's not really going to move. It's kind of a swivel. At the same time, if you move the vertical asymptote up by 2 units along the y-axis, it's not really going to look any different in that sense either. So for this reason, let's just redraw the vertical asymptote going along the y-axis. Alright, so that doesn't really look any different than what the vertical asymptote would be for our base graph. So with all that in mind, let's go ahead and sketch out the remaining part of this graph. Basically what you do is recreate the shape from the reflected graph, now shifted up by 2 units. And that right there would consist of our final graph, or give us our final graph. Alright, so that's the sketch of the function f of x. What I'd like to do next is provide you with some of the details regarding the function. As demonstrated in class, we were looking at the domain, the range, equation of the vertical asymptote, and then the new location of the original x-intercept. So let's go ahead and start with the first part, which is the domain. Let's say d equals. So again, just a quick reminder, domain stands for all the x values being used for the graph. And we're going to base our domain on our green graph here, our final graph. One thing you might want to note that's helpful is that this green graph is entirely to the left of the y-axis, meaning that the only x values you'd be using to produce this graph come from negative infinity and go all the way up to the vertical asymptote, which, spoiler alert, is at x equals 0. So for this reason, the domain is going to be parentheses negative infinity comma 0. Those are all the x values that would be generating our green graph. As for the range, because our graph goes up to positive infinity and also down to negative infinity, depending on which way you trace it, and it's fully connected, the range is all real numbers. Next is the equation of the vertical asymptote, which, as noted, the vertical asymptote is crossing the x-axis at x equals 0, which happens to be the original location of the vertical asymptote without any transformations. So our equation is x equals 0. Last but not least, the new location of the original x-intercept. All right, the original x-intercept is at 1, 0, but because of both the y-axis reflection and the shifting up by 2, it's now at -1, 2. So I'm going to write it out this way. 1, 0, move to -1, 2. And if you want to note that on the final graph as well, that'd be helpful for me. All right, and that's how you do it. There's the sketch of f of x using transformations, along with some of the nice and juicy details of it. Let me just close that off. Feel free to let me know if you have any questions. Otherwise, thanks for watching.